move on to the big topic today, which is 1.4, and it's all about this concept of an inverse function. In mathematics, we define operations, like we find addition, and then we found the opposite of addition, which is subtraction. We define multiplication, repeated additions, and then we found its opposite, which is called division. We do inverse operations. We use the distributive property, and then we did the opposite or factored. So we always look for undoing whatever we do. And that's the idea of what an inverse function is. And let's start with a very simple and, if you will, basic definition. I'll put this over here. It's in the textbook too, so we don't have to worry about that. So here's our definition. And we're going to revisit this whole concept of inverse functions throughout the course. This is not the first, this is the first, but definitely not the last time you will see this of inverse functions. So I want to start it early so you get comfortable, because it is a confusing thing. And here's our definition. So let f of x be a function. So we have to have a function to start with. It has to pass that definition for a function. No repeated x coordinate. And described by a set of ordered pairs. A set of ordered pairs. Now they can either be given directly, or they can be given, to an equation. Y is equal to some arithmetic or algebraic expression. Ordered pairs, x comma y. Order is important. X is first. Okay. Now, the inverse function, that's what we're defining over here. The inverse function, okay, exists. Okay. Well, the inverse, let me say, the inverse function of f of x is the set of ordered pairs when I swell up the x and y's. Set of ordered pairs y comma x. Notice what I've done. I just flipped the x and y. Now, this is a function. This function exists provided y comma x, that set of ordered pairs, is also a function. Meaning, now instead of just the x value not being repeated, to be an inverse function, the y value cannot be repeated. Okay. So that's what we define. It will undo. Meaning, this function takes my x to y, and this function takes me back from y to x. It does the opposite. So this is a mapping. Sometimes you think of a function as a mapping. So for every x value, I get a y. So this maps from x to y. That'll take me to the y. This will take me from y back to x. Takes me back to where I started from. That's an inverse function. Okay, now how do we want to represent that? What sort of notation? This is where it gets a little bit confusing. So we'd like to represent our inverse function. So here's the notation that we're going to adopt. We're going to use the -1 superscript. Now, this is where it gets confusing. This is the notation for the inverse function. We're going to take f and put a superscript -1 of x. And you read this is read as f inverse of x. This is not the same as this. The confusing part is this. For example, if I went back to section 1.2, and if I were to look at some problems in that dealt with reciprocals. So let's say, for example, I have f of x equal to 1 over x minus 3. And I go back to this notation, I said compute the following. Take f of x and take its reciprocal. Notice there's a difference here. Over here, what do? Well, like my f, plug it in, 1 over x minus 3. This is the reciprocal notation. So this notation is not inverse notation, it's reciprocal notation. And that's where it can get confusing. We do that very frequently in mathematics. We use the same symbol to represent something else. This means I just flip this, and this becomes x minus 3. So this does not equal that. One is an inverse function, and the other is a reciprocal of a function. Not the same thing. So be very careful about that. I like to point it out very specifically. So this is one way of, you'll see that notation when it's outside as opposed to being right next to the function. That means this means we're flipping x and y coordinates. This has nothing whatsoever to do that. That just means we're taking the y value and taking its reciprocal. So if you looked at this notation, that would give me x comma 1 over y instead of y comma x. This gives me y comma x. This gives me comma the reciprocal of the y value. It's confusing. But that's what we're going to be using for notation for inverse function will simply be that. So here again, the notation we'll use is simply f inverse to the -1 of x. And that's our notation for the inverse function, not the reciprocal of a function. Okay. We'll see it throughout, but I just want to make that because some students get confused and they don't know the notation. Math is a language, and I think we probably should have used something else than that, but so be it. That's why it's chosen because a lot of students get confused. Okay, so now that we defined it, we get a sense for why we might need it. We needed to undo the operation of a function to get us back where we started. The real question that becomes, how do we find inverse functions? So given a function, can we find the inverse, and how do we do it? Does it exist? Is there an associated inverse function? So this is what we're going to look at now. The last part of this is, how do we go about, how do we find inverse function? Okay, so a couple of different ways. One is algebraic. If I'm given its algebraic representation, I'll show you how to do that as well. Okay, let's start with the easier one. It's a picture. Let's start with the graph. Meaning, I start with some function over here. So here's my function. I'll take this as my cubic function over here. That's my f of x equal to x cubed. Here's my y, there's my x. And then I look at the line. It's supposed to go to the origin. I don't have it drawn perfectly there. Take a look at the line y equal to x. So this is the line y equal to x. And what did we do? Well, remember we had our function fx, which was defined as some ordered pair x comma y. We wanted to find an inverse function, f inverse of x. To do that, we just swap the y and the x's. We just change the order. X becomes y, y becomes x. We just flip them around. I mean, the same x and y combos are there, but I place the y value first. Well, what's happening graphically with that? Well, it's very simple. What we're dealing with is the following. So we have our little function over here, f of x equal to x cubed, and we're swapping x's and y's. That means the x-axis becomes the y-axis, and the y-axis becomes the x. That's equivalent to taking a line y equal to x and simply rotating about that line, and over here I get a new picture. So now what I have, instead of this graph, I have the following graph. This graph that comes out is my function f inverse of x. And we're going to find out in a minute. I'll be able to show you how to write that algebraically. It's nothing more than the cube root of x. But that's how you find it. So if you want to see a picture of it, you draw your graph of your function, and then simply draw your line y equal to x, and then flip it about that. So the y-axis comes down and becomes the x-axis. The x-axis comes back up and becomes the y. So y becomes x and x becomes y. And the resulting, if you look through the paper, is my inverse function. And that's all it is. So it's very, very simple in that regard to do it graphically. And it makes sense, because what are we doing? X is becoming y, y is becoming x. So the x-axis turns into the y-axis turns into the x-axis. And that's very easy to see a function, f of x, the black graph curve here, and my inverse function, let's pick up inverse, the blue line right there. So that's how you do it graphically. Very simple. Anything you can. Now, notice this is a function. But what if I took something like this? Okay, here's my f of x. I'll make a new one over here. So that's my function. That's a squaring function. And if I do the same thing, draw my line y equal to x. Here's my line y equal to x. And then I flip it. So I rotate everything about the line y equal to x, and what's going to happen? This thing is going to start looking like this. It's going to look like that. Now this is a problem. This is no longer a function. What I'm calling f inverse over here, it has a difficulty. We're going to learn how to correct that shortly, but my f inverse causes some difficulty of x. Because if I pass a vertical line, I hit in two places. We're going to start talking more about domains and ranges. We're going to show how to rectify that to some extent. We'll talk about something called a restricted domain. And what we will get out of here very shortly, not just right now, but we're going to build up slowly. We don't have to do everything at once. We're just going to get the top portion of this. I'll put that in green, and that's going to be my inverse function over here, which happens to be the positive square root of x. There's the positive, the top is a positive, the bottom is the negative. We're going to show algebraically where that kind of intervenes and causes us difficulty. Okay, so you should be able to do it graphically. That's very simple, as long as you can do that physical operation of flipping your paper. Well, I'd like to do it more algebraically. So let's see how we do the same thing algebraically. This is where it gets a little more. Here's where you have to practice your algebra to get various types of functions. So here's the algebraic approach. So we start with some function. Let's start with a simple one. Here's some examples. So let's take a line, a straight line. Y is 2x minus 3. Well, what did we do? The first step is to get our inverse, is we have to place y with x and x with y. So we swap the x and y's. So the first step is you swap out your x and y's. So the first step over here is swap x and y's, the x and y's. So y becomes x, and x becomes y. Okay, so the next thing to now do is that y is what we need to solve for. This was solving. So the second step over here is you solve for y. Because that is my inverse function. Now that's set up that way. I swap the x and y, that becomes the inverse function. So I go through and perform the algebraic steps of adding 3 to both sides and dividing by 2, and hopefully everyone can see that you can write this as y. I would add 3, so I'd have x plus 3, adding 3 to both sides. Then I need to get rid of that coefficient of 2 in front of the y, so I divide everything by 2. Then the last step is that y becomes my inverse function. So now see, we place y with my inverse function notation. So I have my f inverse x is simply equal to, I'll put it x over 2 plus 3 halves. Just write it. I'll show you why I want to write it out in a second. That's my inverse function. Now, let's see if I can verify or validate that. We'll do a graphic. I'm just saying what I just do worked. It's just giving me the same answer. Well, I can draw the graph of this. Like down over here. And we'll draw the graph of the first one. Minus 3. So here I go down here, my y-intercept is over here. And I go up 2 over 1. 2 over 1, so it's right over here. So you can see the graph of this looks something like this. Okay, now let's draw the graph of the other one. So my y-intercept is 3 halves. It's 1.5. That should really be, I don't know quite how it's drawn nicely here. It should be halfway between this. If I had good, good graphing and everything. But what happens is this goes and has a y-intercept now of 3 halves. So that's passed through there. And now I go, up 1 over 2. So it looks something like that. And I go up 1 over 2, something like that. So this is the graph of that over here. This is my y equal to x over 2 plus 3 halves. And this is my y equal to 2x minus 3. Now let's take a look at our line y is equal to x. Here's the line y is equal to x. And notice if I were to flip these, that's exactly what I have. If I flipped about the line y equal to x, the green curve, the green line becomes a blue line, and the blue line becomes a green line. It just flips it. So it is exactly correct how I want this. And I can see right over here, this should go right through that point there. If I had nice graph paper, it would work out perfectly. But that's what you do. So I now have my function, and I also have my inverse function. We're going to see that they're going to be related when we start looking at more on functions. Let's take a look at another one. Let's take a look at our square root function. Let's try another one. Let's try the y cubed. I can look at another example. So here's a second example. Let's say y is equal to x cubed minus 1. Okay, let's go through the algebraic approach. First step, I swap the x's and the y's. So I'm going to write that now as x is equal to y cubed minus 1. So x is equal to y cubed minus 1. So now what I want you to do is I want you to take this. I now want you to solve that for y. Can you solve that expression for y? Go through the process. You don't have to go to the picture of it. All algebraic minute. You don't need the picture. I just want to make sure you can do the algebraic manipulations to get that. So try that just there. And I'll go through it and show you what the proper way should be. And hopefully you're going to get this. So you should get the cube root of x plus 1. Does anyone want to see how I got that algebraically? That's uniquely solved for y. There's no plus or minus, there's no two possibilities, it's just one possibility. Does everyone see how to go from here to here? Just raise your hand if you're not seeing it, or just, ask a question. Everyone's got that, not too bad. Okay, let's take a look at another one. There'll be more to practice. You'll get to practice some more of these algebraic finding of the inverse functions. We're talking more about the domain and range, but we're not quite there yet. I just want you to get comfortable. And then we're going to show exactly what we mean by undoing the function later on. But we have to introduce something called a composite function. So let's try another one. I get y is equal to x squared plus 2. This one's a little more subtle. Try and find the inverse of that. You will have a problem here. And we will talk about that. You will have a problem. And then we'll talk about later on, not in this section, but later on, how to rectify some of those problems. And I'll show you when you swap the x and the y and solve for the y, you get the following. So if you go through that process, that's what you would get. When you take the square root, it's plus or minus. You always have to consider not just the principal root, but also the negative of that root. This is what causes a problem. For every x, it gives me a positive and a negative value. So I get two possible values. So that is not a function in that regard. It also has another problem, is because the square root is not defined when what's underneath it is negative. So we have some other difficulties there. So for this one, it does not have an inverse directly. We have to do some work. And we'll be looking at other chapters to find out how we can create an inverse function out of this. And we're going to see later on, we're only going to take the positive. So we'll get our inverse function simply by eliminating the negative, the possibility of getting a negative out. So we'll take it as just being the positive square root of x minus 2. And if you're looking at graphically what we've done, well, here's a graph of that x squared plus 2. Here's our line, if you will, y is equal to x. And if we flip this over, well, this is going to come over here and it'll look something like this. And we're only going to do the positive, the top half of that. We're not going to reproduce that part of it. We're only reproducing this bold portion of the curve. because that just will do just the positive square root, not the negative that goes underneath. And that's what we're going to be calling our F inverse. And we'll talk more about that later on. And we have domains and ranges, the set of the inputs, the set of the outputs we'll discuss. But that's about it. So let me give you one last example to try, a linear one, and then we'll be done for today. Now, we're not finished with the inverse function. This is the very start of it. You're going to see it all throughout, especially when we get to different types of functions, such as trig functions, and as well as logarithmic and exponential functions. Let's try this one last example, a simple one, and see how well you can do that. So here's my example. Y is equal to minus 3x plus 4. What I'd like you to do is find the inverse function of that. So see if you can find that. Do that on your own, algebraically. Right now it's still a little nebulous about why it's an inverse function, but we'll show you exactly later on why. At the end, I want to have my, this is y equal to f of x. That's my y, it's f of x, and I want to have my f inverse and see how that is defined. I chose to write it this way. You can put the negative down there. I just chose to rewrite it. Or like that. Different ways of expressing the same thing algebraically. Or a lot of you might have had this. So 3 different ways. You know, usually this way or that way is preferred. You don't like to divide by a negative. You don't like the negatives in the denominator there. So one of these ways are the more preferred as opposed to that. If you want to see in the remaining, couple minutes, 2 minutes that we have left, how I got from here to one of those 3. Is everyone comfortable? Okay, so let's kind of go through show the process very simply. First step, I replace the y with the x and the x with the y. So I'm going to rewrite this as x is equal to minus 3y plus 4. And then I want to solve for y. So I subtract 4 from both sides. So I get x minus 4 is equal to a negative 3 times y. Then I have to have that solve for y, so I have to remove the coefficient of negative 3, so I divide both sides by negative 3. Let's just flip it around by the transitive property. Y is equal to x minus 4 over negative 3. Now, if I don't like a negative here, what I can do is just multiply top and bottom by negative 1. Okay, so down here, that gives me a minus x plus 4, negative 1 times negative 3 is positive 3. And I can just flip and put the x over there, or I can write it as negative 1/3 x plus 4/3. That's all it is. So this is the algebra. This is the algebra you should be getting very comfortable with. If you're not, practice some more of those homework problems, not homework problems, but those extra problems I gave based upon the algebra, which is available on a link on our Blackboard website. So that's it. You're learning how to find, and this is my inverse function. A function that'll undo this function over here. It's a straight line function. So that's, if you looked at that, you graph it, it's a straight line down, slope of 3. This other one, notice it's still going down, but it's not as down as rapid rate as the other one. It'll still go down, but at a different rate.